Hi students, welcome back. Now let's see the next concept in the compiler designs was a storage organization. Okay, so how the data is going to be stored in the compiler. So let's see how this, if you take the symbol table. So in the symbol table, how the storage is going to be organized. So let's see. The executing target programs run its own logical address space in which each program value has a location. So whatever the program, that is a program is a series of steps. Okay. So here each program value, whatever the values that are assigned to that variables, that will be having one location. So the management and the organization of this logical address space is shared between the compiler, operating system and the target machine. So the logical address, you already know the concept of the logical address and physical address. Okay, so the logical address, whatever we are use it to, this will be active at the compilation time. So after the program is executed, that logical address will becomes the free space. Okay, so it's a temporary address. The executing target program, whatever the program that you want to be executed, okay, so means that you want to be compiled, it has to run its own logical address. It is having a separate logical address space. So in that logical address space, each program value has a location. Okay, so the whatever the management and the organization of this logical address space is shared between the compiler, the operating system and the target machine. Okay, means the logical address space will be managed by all these three components: the compilers, operating system and the target machine. Means it's a software. So these three softwares are going to be managed this logical address. Whereas this logical address has the values that are stored in a particular locations which are used to run the program. The operating system maps the logical address into physical address, which are usually spread throughout the memory. Okay. Now let's see how the memory is divided into the subdivisions of runtime memory. So whenever you're compiled, after the compilation, you want to execute the program. So that execute the program comes in runtime memory. It uses the runtime memory, which is the logical address. You have to think this is a logical address. Let's see the subdivisions of this runtime memory. So the complete memory is divided into different divisions, different parts. So code, static data, stack, and from some free space will be available, and the heap. Okay. So what type of information will be stored in this block? Memory location for code are determined at compile time. So this code block consisting of a memory location for code which are determined at the compile time. So at the compile time, we have to retrieve the values from the particular memory location. So those values, those information will be stored in this code block. Now let's see the static data. So here the static data, locations of the static data can also be determined at compile time. Okay, so the locations of static data can also be determined at the compile. So this is also used at the compile time. Now coming to the stack. We know that the stack is a temporary data storage. Here the data objects allocated at runtime. So nothing but the activation record will be stored here. The activation record means it is the variables that we are using at present, and the execution part, that active part, you call it as an activation record. So all the data objects allocated at runtime will be stored in the stack. So whenever we are taking one by one, whenever the stack becomes empty, your program will be executed. Means you are taking all the information and you executed the program. So the activation records will be stored in the stack. And this is a free space which is used for, suppose if you are using more amount of data or some other operations for the future purpose, we are using this free memory. And the heap. So here this is the other dynamically allocated data objects at runtime will be stored in the heap. Example for this is malloc area in C. So when you're writing the C program, if you're using the malloc concept, so that type of information, that is a dynamically allocated data objects are stored in this heap. Okay, so this is about the subdivisions of the runtime memory. So the storage organization consisting of these parts. Now coming to this, the runtime storage comes into blocks. So whatever we are seeing here, the runtime storage, this is a completely runtime storage. This runtime storage comes into the blocks, where a byte is used to show the smallest unit of addressable memory. So using the 4 bytes, a machine code can form. We know that using only the 4 bytes of information needs the machine word can be formed. Machine word is nothing but in the form of ones and zeros. The object of multi-byte is stored in consecutive bytes and gives the first byte address. Now let's see. The runtime storage can be subdivided to hold the different components of an executing program. So whatever the program that you want to be executed, that you want to be compiled, so that program where the runtime storage is subdivided to hold the different components in the whatever the program that you want to be executed, means the complete program will be divided into different components. Okay, so generated executable code, static data objects, dynamic data objects, head, automatic data object stack. So whatever we are shown here, this is the subdivision of runtime memory. So that here they are written in the points. Generate executable code. So here it consisting of the executable code in the code block, and the static data objects, and the dynamic data objects. So heap is the dynamic data objects, and whereas a stack is the automatic data objects. So all the executing program, whatever the program that you want to be executed, that program is divided into subdivisions of runtime memory. So this is about the storage organization while you're executing the program in the compiler. Thank you.